And I go out and I watch the moon every day to do the phases. Patricia, do you want to know how the phases work?
Oh, she's got this down cold.
That's been something that's been bugging me bigger than almost anything involving all of this.
This I have proof positive. Or not proof positive, but it's pretty good.
It pans out.
It pans out.
Yes.
Okay, I'm going to share a screen. Let's see how well I can do this to you without the... Oh, you know what? I can do it in a picture here a little bit first. Let me do it here in color.
Okay.
I was looking at the moon last night. And
just a little thing to throw in. You look at the sun, and the sun veers out until it hits that flux point where it bounces away and hits the other flux point. Okay. So there has to be flux points this way too for the moon to go up, bounce off, and bounce back up.
Of course. Yeah, that's part of the field. That's the toroidal field. It has to be there. You're right.
Are they seasons as it does that?
This does seasons. This does it all. Let me show you. Again, I don't have the artwork of the presentation done, but I have it in my brain. So, okay, imagine the sun's path, the yellow line, and the moon's path is the blue line. Now, I'm taking this from a picture of the sun and the moon's path out of all of the science. If you look up lunar nodes, you will come up with this picture.
Okay, and let me stop her right there. Hang on a second.
Okay.
And also, to understand this, you have to understand that these two circles, as the year goes around, they're actually going like this, up and down. Okay? So you'll have the sun higher at some points, and you'll have the moon higher at some points. In other words, they're kind of teeter-tottering back and forth.
It's a monthly teeter-totter.
That's important to know.
The sun and the moon are teeter-tottering every month, and it creates the phases within the heights of the sun and the moon, but they're also expanding and contracting between the fields. So this is how,
they ride between
them.
The tropics.
As they ride between the tropics, this is how it works. Which I'm going to keep this color, the sun and the moon colors in your mind, and bring it up on the screen.
So the map shape is egg-shaped, somewhat circular, with an ice ring. Okay.
Yep.
And maybe more land. We don't know.
Yeah, possibly.
The cleft above Hawaii.
The map shape doesn't have to be egg-shaped. The energy's egg-shaped.
Got it.
But there could be, this, like with the free energy generators, which have sequencing of magnets, but have one slot empty, so that the magnets will not clog with the next.
Exactly.
Yeah.
Exactly, Antonio. You got it right on the money. That's what it is. It's literally a magnetic field that is being stepped through its phases.
Okay, let's view this image. You're going to bring that up. Okay, remember the picture and how I had it?
Yeah.
So don't lose me. This is the sun, and picture for all practical purposes, picture the sun's path over your head flat, like on the same plane as you.
If I can just say, Cami, Patricia, if you remove the globe with your mind, remove it from there and put the flat...
Get rid of this entirely and put a flat world underneath it, with this being
underneath
the equator going here to here. So it's right over, now it's over the solstice, right? Flat line in the equator. Can you draw that so it's perpendicular underneath it on your flat world, going around the pole? So think of this just as your North Pole star.
Yeah.
Okay?
Good way to look at it.
Okay. Now, things to know about these orbits. First of all, and these are all scientific facts that were just put into motion. They just told you the wrong direction on everyone. First of all, these orbits are similar, but they're not exact. So think of a spirograph. Think of a spirograph where you're doing almost circular patterns that they'll lay on top of each other this way sometimes, and sometimes they'll lay, like this is a little bit out of phase from it. And certain number of rotations in that, they will lay right on top of each other where you draw the same circle. Does that make sense?
Yes.
Okay, I need it to make sense.
Where they cross over, the two circles cross over.
Okay, so follow me, Patricia. Okay, now let's put you in the sun. It's noon where you are in Dallas right here, and you're right here. Houston. Okay, I put you in Dallas. I like Dallas better than Houston, I'm sorry.
Hey, I don't like either, so.
I like Dallas. I like Texas a lot. People are really, really nice. And I like San Antonio and Austin in that area more than
people are nice. This is true.
They're really, really nice. Okay, so your sun is right here, and it is noon. So it's over your head and everything. And right now it's the summertime. Actually, they really have it right above your head, right?
Mm-hmm.
Okay, so we're gonna pretend, and that's noon every day. It's always there at noon. So the sun is right here. So you're following me?
Yes.
When the moon is new, it's right here. And it's you have it underneath. The sun is illuminating or fluorescing the top part of it, and you're not seeing the bottom. It's washing out. It's blue. It's washing out in the sky. And it's right next to the sun in the sky as it's traveling around.
Which, by the way, is a property of celestine like you wouldn't believe.
Which is, by the way, this stone will, as it is exposed to radiation, turn more blue. The closer it is to the source, it's going to do more blue, and it will turn more white the further it gets away. Oh.
It's our favorite place.
It's where we want to, when we get this, or like, that's where we should all have a retreat there. Just live.
I think we should all go and hang out with Nassim.
It earns its nickname Paradise, believe me.
So that would be the ground. And the ground is what's doing this and that, right? Let's see if I can get this to do it for you. Okay, so a half moon.
Yeah.
A new moon.
Yeah.
A full moon. Oops, I'm holding it backwards. Because on the altitude, it's one directional. So you have full, and then as it goes around, you're going to get your crescents. If I was holding it directly, you get your perfect crescents coming.
Mm-hmm.
And notice, in order to do this, it requires a relatively close light source.
Yes.
Same with the sun.
Otherwise, it would just
Do you see how
in the light, right?
From underneath, which I'm giving you guys the underneath view, from underneath you see the half and then the waning.
Right.
You can get the perfect crescents going on both sides. So waning and waxing getting higher and lower, but because of the fact that you're viewing it, you're seeing the below view. Here's your half moon. Well, is crescents out perfect. It does it perfectly if you hold the light.
Something that you also need to know about this, guys, is that
almost a full
the
moon.
sun is not reflecting the light. The sun is fluorescing the moon. And that
I was just going to say, that's
Right,
where
that's
they
what-
get that from, the
Yeah, look, Nathan.
half story.
Yep. That's why
It's making it. I have the white and the fluorescent lights in it. It's actually making it glow. Like phosphor, like when you put these minerals in a light box.
Oh my
you guys
God.
see minerals in a light box. So it can't
Look
go
at
through
that.
all of it. So when it does half.
right.
I'm
it's
sorry, I have to
actually
be really stupid. I don't understand what you're saying. So,
Right.
what you're saying is the moon. What are you saying is the sun. I don't get it
Okay.
at all.
Let me
Let's show
Okay.
let's do it.
Nathan, I'm
let's
going
do
to
it
have
this
him
way.
do it for you.
Let's show this.
I'm going to go
Alright.
smoke. I'll be back, boys and girls.
Okay, Nathan.
Okay, Nathan, so
What they have is a stone called celestite, which has really peculiar qualities. That it is highly magnetically impermeable, and it reacts to radiation. Depending on the type of radiation, it will give a different color light.
correct.
Will
Yeah,
have
I got all that. What I'm saying is, are you proposing to me that there's a giant ball of that stuff that you've just held up balanced on a magnetic field?
That is exactly what we're proposing, yes. And it not only does, when you look at it close, it doesn't not look like celestine, but celestine has all the characteristics that you would expect, including this. Here's the sun, and it's not visible light, okay, that's fluorescing the moon. It's the radiation, just like that. Same principle, exactly. So the moon is self-illuminating, but get this, when the moon illuminates, it illuminates just like this light does in a cool fluorescent light. A cool light,
yeah.
right?
Cool.
And
So-
when you think in terms of that much bulk being held up there, if you start to think instead of the amount of force needed for the boundary or the firmament to be up there, there's more than enough force for something
Well,
to be
you
up
say
there.
that much bulk, Antonio, but I've been slowly edging towards it being much, much, much closer and much, much, much smaller. What do you think, Bob?
You know, I can't disagree with that. It's funny because I was talking to Robert Bassano of all people yesterday about that, and because he was making his assertions that he thought, well, actually, he uncovered some documentation that was saying that the moon is like yeah, much closer, like, somewhere just over the 100-mile mark, which
that's exactly what I said. I said if you lay out a couple of thousand miles, which is a huge vast distance, and then tip it on end, is that the distance you see between you and the moon? Absolutely not. If you were to lay out about 100 miles and tip it on end and look at the moon, just looking at it, it looks about 100 miles up. That's what it looks to me.
It kind of looks that way, and honestly, the only thing that doesn't make sense about that to me is when you do the Pythagorean triangulation on it, it comes out to be a little over 3,000. So I can't explain that unless it has something to do with the point of reference that you're taking those readings on the moon on, because it is 33 miles across after all.
Could it be as simple as, instead of it being 100 miles, it's 300 miles, and the extra 0 was just thrown in there as a value?
No, I think it's much smaller than 33 miles. I don't think it... I mean, for that rock you just held up, Bob, I mean, let's be realistic. No matter how magnetic it is, it can't be massive, no matter how big the forces are. It's got to be relatively small to bob along on these magnetic forces. So it can't be massive. It just can't be.
Well, it doesn't have to be massive, because one thing that I can tell you about geoids, or this particular celestine, it is a geoid that grows with a hollow center. In other words, it's hollow. And remember, okay. NASA's even given us those hints. They said, yeah, well, we hit the moon with something and it rang like a bell.
Rang like a bell, yes.
And that is exactly what would happen if you had a geoid of this and hit it, it would ring like a bell. This has all the properties that responds electromagnetically and photooptically to the long wave ultraviolet, to the short wave ultraviolet spectrum. It responds to all of those. It is also temperature, I forgot what you call that term, but it also responds via temperature on its luminescence as well. So, I mean, this has, when you really look at the characteristics of celestine, it has everything we're looking for. When you look at the C's, like and the Maris, Maricris and stuff like that, what you're actually seeing is you're seeing the facets of this stone. And here's another interesting part about celestine, is if you put it in water, it will slowly but surely decay, but it decays in perfect circles, perfect little crater-like circles.
With
exactly.
With a small divot in the center.
Huh?
With a small divot in the center.
Yes, it can do that too. And you can actually see that in this particular stone. I don't know if you can get the resolution on this, but yes. So when you examine the surface of this piece of celestine, and you also examine the facets and look at the moon and just kind of imagine it scale up, it's a match. But like I said, the beautiful part about this is that it fluoresces sky blue during the day, which is just exactly what we see on the moon.
In the day, yeah.
And the grey patches.
Yeah, and the grey patches, the whole 9 yards. It's exactly what you see in this.
And it's celestine or celestite. I guess it has two different names. And I was just reading right now that it says it has some strontium has that.
Yes, yes, it does.
Okay, well, well, the next thing I've got a slight issue with is still hollow or otherwise is bobbing a giant spherical rock on a magnetic field. I mean, don't get me wrong, I've seen the magnetic stuff do its stuff, but I mean, do you think? I mean, I know we see the moon doing this, so obviously there's something there doing that. But do you think it's something we could replicate in small scale?
John Hutchison already has done.
Yes, yeah, exactly, Hutchison. And the other thing, Nathan, is that, like I said, if this is indeed in some sort of liquid, like space is in a liquid,
plasma,
depending on the viscosity of what that liquid is, this could also be floating a little bit.
I'm with Cami on plasma, sorry.
Wouldn't eventually because it disintegrates in water, wouldn't eventually, if space is water, the moon disintegrate? Or is it not in the watery area, the water is above that?
No.
Not sure, but what I can see, that's why I wanted to see how old or how far back we could get old pictures of the moon and see if there